All right, so we understand a simple example of using Spark. Let's build upon that and start doing some more complicated things. So a powerful thing to do with RDDs is put more structured data into it. So one thing we can do is put key value pairs of information into Spark RDDs, and then we can kind of treat it like sort of a very simple database, if you will. So let's walk through an example where we have sort of a fabricated social network set of data, and we'll analyze that data to figure out the average number of friends broken down by age of people in this fake social network. And we're going to use key value pairs in RDDs to do that. So let's cover the concepts, and then we'll come back later and actually run the code. Okay, let's build upon what we've learned about RDDs and extend it to a new kind of RDD, a key value RDD. And we're going to do this in the context of a real example where we're going to look at some fake social network data and try to figure out the average number of friends broken down by age for people. So RDDs can hold key value pairs in addition to just single values. In our previous examples, we looked at an example where an RDD included, for example, lines of text for an input data file, or an RDD contained movie ratings. So in those cases, every element of the RDD contained a single value, in that case either a line of text or a movie rating, but you can also store more structured information in RDDs. So there's a special case where you have a list of two items that it contains, and that is considered a key value pair RDD. And these are really useful things because once you start storing key value pairs in an RDD, it looks a lot like a NoSQL database. It's just a giant key value data store at that point, and you can do some things where you can aggregate information by key values, for example, and that can come in handy, for example, in this example we're about to do. So syntactically, there's nothing really special about key value RDDs. It's all kind of magic in Python. If you are storing a list of two items as your values in the RDD, then it is a key value RDD, and you can treat it as such. So here's a simple example. If I want to create a totals by age RDD out of a original RDD that contains a single value in each element, my lambda function here, x, can take each, say, rating, and then, or each number, whatever happens to be in x, and transform that into a pair of the original number and then the number 1. So the syntax with the parentheses just indicates that this is a single entity as far as Python's concerned, but it consists of two elements. It's a list of two things. And in this example, the first item will be the key, and the second item will be the value. And again, the key is important because we can do things like aggregate by key. And that's all there is to creating a key value RDD. And it's also okay to have complex things in the value there. So I could keep the key as being the original value here from the first RDD and make the value itself a list of however many elements I want to. So I'm not limited to just storing one thing in the value of a key value RDD. I can store a list of things there if I want to as well. And we're going to do that in this example too, just to illustrate how that works. So like I said, one of the most useful things you can do with a key value RDD is reduce by key. And what that does is combine all the values that are found for the same key value using some function that you define. So for example, if I want to add up all of the values for a given key, let's say all of the numbers of friends for a given age, just to pull that out of the air, something like this would do the job. So when you call a reduce function in Spark, it will get not just an x but also an x and a y value. You can actually call those whatever you want, but what you need to do is define a function that defines how to combine things together that are found for the same key. And in this case, our function is just x plus y, so it says we're going to keep adding things together to combine things together for a given key value. So, for example, again, if I was doing a reduce by key on a key value RDD where the keys were ages and the values were number of friends, I could get the total number of friends found for that age with something like this, because every value that's found for that key will be added together using that function that just has x plus y. There are other things you can do as well with key value RDDs. You can call group by key, so if you don't actually want to combine them together quite yet, you can just get a list of all the values associated with each key using group by key. And you can also do sort by key, so if you want to sort your RDD by the key values, that makes it easy to do. And you can also split out the keys and the values into their own RDDs using keys and values. Don't see that too often, but it's good to know that it exists. And like I mentioned before, you've kind of created a NoSQL data store here, right? It's a giant key value data store, so you can start to do SQL-ish sorts of things since we have keys and values in play here. We can do joins and right outer joins and left outer joins and cogroup and subtract by key. So these are ways to combine two key value RDDs together to create some joined RDD as a result. And later on, when we're looking at making similar movie recommendations, we'll have an example of doing that by joining one key value RDD with another to get every possible permutation of movies that were rated together. Now, this is a very important point with key value RDDs. If you're not going to actually modify the keys from your transformations on the RDD, make sure you call map values or flat map values instead of just map or flat map. And that's important because it's more efficient. It allows, getting a little bit technical, it allows Spark to maintain the partitioning from your original RDD instead of having to shuffle the data around, and that can be very expensive when you're running on a cluster. So anytime you're calling map or flat map on a key value RDD, ask yourself, am I actually modifying the key values? If the answer is no, you should be calling map values instead, or flat map values. And just to review, again, map values will have a one-to-one relationship. So every element in your original RDD will be transformed into one new element using whatever function you define. But flat map can actually blow that out into multiple elements per original element. So you can end up with a new RDD that's actually more, longer or contains more values than your original one with flat map values. Now, one thing to keep in mind is that if you're calling map values or flat map values, all that will be passed into your function that you're using to transform the RDD will be the values themselves. So don't take that to mean that the keys are getting discarded. They're not. They're just not being modified and not being exposed to you. So even though map values and flat map values will only receive one value, one value, which is the value of the key value pair, keep in mind the key is still there. It's still present. You're just not allowed to touch it. And I realize this is a lot to digest. It's going to make a lot more sense when we look at a real example. So let's look at a real example. Bear with me. So to get back to what we're going to try to do to illustrate these concepts, what I've done is generated a fake data set just completely at random, and it represents a social network. And what it has in it on every line is a user ID, a username, the age of that user, and the number of friends that user has. Okay? So for example, user ID 0 might be named Will, and he's 33 years old and has 385 friends. And these ages and numbers of friends are all completely assigned at random, so don't associate any sort of deep meaning to them. And you might notice that I'm a Star Trek fan here. So that's our source data that we're going to work with. And our task is to figure out the average number of friends by age. So for example, what's the average number of friends for the average 33-year-old in our data set? Well, let's figure that out. So our first step is just to parse that data into what we need. And, typically, nothing special here. We're just going to start by creating a lines RDD, that is calling text file on our Spark context with our source data. And that's just going to give us an RDD where every individual line of that comma-separated value list is an individual entry in our RDD. And now things get interesting. So I'm going to transform my lines RDD into an RDD, very creatively named, by calling map on it. And I'm passing in the parse line function to actually conduct that mapping. So every line from my lines RDD will be passed into a parse line one at a time. And I'm going to parse it out. And first thing we're going to do is split it based on commas, and that will bust out the different fields we need. And I will then extract the fields that I'm interested in. So if I'm just trying to figure out the number of friends by age, all I care about is the number of friends and age information. The user IDs and the usernames are irrelevant, so I'm just going to discard those. So I will extract the age from field number 2, which is actually the third field because we start counting from 0, remember. And this is an important point here. I'm actually casting it to an integer value because I want to treat this as a numerical value. And that allows me to do arithmetic operations on it later. Now, if I didn't do that, it would just keep treating it as a string, and I wouldn't be able to do things like add them up and divide them, which I'm going to have to do if I want to get averages at the end of the day. Similarly, I'm going to cast the number of friends to an integer value as well, using the syntax int, in between parentheses. So fields 3 will give me back a string value of some number, and int will actually make sure Python knows that it's actually a number, and I should treat it as such, and I can perform arithmetic on it. And here is where we actually transform things into a key value RDD. So instead of returning a single value, I'm returning a key value pair of the age and the number of friends. So the RDD I'm creating with this parseLine mapper function is creating a new RDD that is a key value RDD with a key of age and a value of num friends. With me so far? So for example, transforming the original data that I showed in the previous slide, the output will be a key value pair RDD that contains something like this. So the first user in our data had an age of 33 and 385 friends. The second user had an age of 26 and 2 friends. The third user was 55 years old and had 221 friends, and so on and so forth. With me so far? This is an important concept to grasp, so feel free to hit pause and stare at the slide a little bit longer if you need it to sink in. Let's move on. All right, so now I'm going to throw you into the deep end of the pool here. Look at that big scary line. But if we break it down into its components, what's going on here is pretty straightforward. What we need to do next is aggregate this information somehow. So the first thing we're going to do, let's just break this down one component at a time. So you see we have sort of a compound operation going on here. We're taking our RDD of age and number of friend key value pairs, and we're calling map values on it. And then we're taking the resulting RDD and calling reduce by key on it. So let's take this one step at a time. We'll start with the map values piece of it. So what this does is transform every value in my key value pair, because remember we're calling map values, so the X that's getting passed in is only going to be the value piece of the original RDD. So let's take that first line for an example. The first entry in our RDD is an entry that has a 33-year-old that had 385 friends. So the value 385 gets passed in through map values for every line, and that's our X here in the lambda function. And our output is going to be a new value that is actually a pair, a list if you will, of 385 and the number 1. And the method behind our madness here is that in order to get an average, we need to count up all of the total number of friends seen for a given age and the number of times that age occurred. Okay, so later on, if we sum up all of these pairs of information, we will get the total number of friends for that age and the total number of times that age occurred once we look at the totals for a given age. So that's kind of our strategy here. Build up a running total of how many times 33-year-olds were seen and the total number of friends that they had. And that's what we're trying to accomplish. But to get back to the syntax here, just to review again, map values will receive each value, which in our case is the number of friends, and output a new value, which is actually a tuple that contains the original number of friends and the value 1. So again, this is an example of a key value pair that we end up with where the value is not just a single value or a single number, it's actually a collection of numbers, a list, and that's perfectly okay. So our output is a new RDD that is still a key value pair, but the keys are untouched because we called map values, and the values are now transformed from just a number of friends to this pair value of 385 and the number 1. Now we need to add everything up together, and that's where the reduce by key part comes in. So again, reduce by key just tells us how do we combine things together for the same key. So again, going back to our example here, let's say that we're looking at every 33-year-old, so we're looking at keys of 33. Our lambda function here takes in 2 values and says how do we add them up. So for example, in this case we have X coming in as 385 and 1, and Y might be 2 and 1, and this just says add up each component. So take the first element of each value and add them together, take the second element of each value and add them together. And the output in this case would be 385 plus 2 is 387, and 1 plus 1 is 2. And we'll keep doing that repeatedly for every time we encounter values for the key 33 and add them all up together. So you see what we have at this stage is the grand total of number of friends and the number of times we saw that key for the given key, and it will do that for every single key. So that's what reduce by key does. And with that, we have the information we need to actually compute the averages we want. We'll do that in the next slide. But probably a good idea to hit pause at this point because even I had a hard time wrapping my head around this at first. So if you want to step through this through your head a little bit more, run through it in your mind, it might be useful. So go ahead and hit pause and let this sink in if you need to. Let's move on. So the last step is just to transform these pairs of total number of friends and number of times that key was encountered to an actual average value. And that's what this final line does with map values. Again, we're just receiving the value part of our key value pair into our lambda function because we're calling map values and leaving the keys untouched. So the age, in this example 33, will remain untouched and not even shown to us in our lambda function. But our lambda function will receive the value, which is this pair of total number of friends and number of times that age was encountered, and just divide the two to get an average value. So The output at this stage for the key 33 would be, we would transform 33 in this pair of the total number of friends, the number of times 33-year-olds were seen, to the number to 33-year-olds had an average number of friends of 193.5. And now we have our final results. All we have to do is call collect to get them and print them out. Now, one thing I want to mention is that, remember, nothing actually happens in Spark until the first action is called. And if you go back to when we called reduce by key, that's actually the first action in our code. So nothing actually occurred in our script until reduce by key was called, which is kind of interesting. And the other action that we have in our script is this collect call. So at both stages, Spark will go out and actually construct that directed acyclic graph and figure out the optimal way to compute the answer we want. So again, that's the key to why Spark is so fast. And there we have it. So let's take a look at the actual code and dive in and actually run it and see what happens. Okay, so that's the overview of how we're going to use key value pairs in our RDDs to actually analyze our data set of our fake social network. And now that we've walked through how that code's going to work, let's make it real. So in our next lecture, we're going to actually run this code for real on an actual data set. See you there.